All right, number 11, again, we want to graph the following function. It says you can check with the graphing calculator. Again, I'm just going to do it by hand and see which one matches. Actually, I will do this one with the calculator. You can graph and see which part match by hand. This one, it takes a little bit of time, but I'm going to go ahead and do it with the graphing calculator just to show you that as well. Okay, so here's our graphing calculator. I'm going to turn it on. I'm going to go to y equal. And of course, you can do this by hand, check the restrictions, and match up some of those parts pretty easily. As a matter of fact, if I wanted to, let's just say look at -3. That's the easiest one to graph. It's a horizontal line at y equals -3. So something like this. The endpoints should be open circles because we don't have equality. A matches, B, C doesn't. So you can have a 50-50 right there. And then you can plug points to one of these. That'll probably be the easiest one, and see is the graph up here or should it be on the positive side. And you can get there pretty quick. But I'm going to graph it and we'll see what it looks like. I would need to change my window so that it matches this one, because when I graph it, it won't look the same unless I change my window. So I would change my X scale going to 20 and my Y scale going to 8. Looks like they're counting by 2, 4, 6, 8 twos on the Y axis, and counting by maybe 5, 10, 15, 20. Nope. 4, 8, 12, 16, 20. So count by 4s. So let's go ahead and do that. I'm going to do second table. Actually, I don't want to do second. I'm going to do second quick. I'm just going to go to window, and my X minimum, I'm going to make it -20. My X maximum, I'm going to make it 20. And then the Y scale, this is what they're counting by. I'll change that to 4. And then my Y minimum, I'm going to change that to -8. Y maximum, change it to 8. And their scale is counting by 2s. All right, so if I just hit graph, I don't have anything. This window should be about the same as that one. So now I'm going to go to y equal and graph. I'm going to do parentheses x plus 1, close, divided by to do the restriction, and we're going to say x is less than or equal to -5. So open parentheses, x, we're going to do second test, and then we're going to do the less than or equal to, which is number 6, and then -5. Now if I graph, I should see a part of a graph. So I see a part of my graph coming from the bottom that would match up with D. Okay, so based on knowing this one, that will match up with D. If I go to y equal, I'm going to go down to y2, and I'm going to graph the next part. So which is -3, which I'm always graphing in parentheses when I'm doing piecewise and giving restrictions. Divided by, and then I'm going to open parentheses. Now you can't do a double-sided, you have to do one at a time. So I'm going to do -5, and then I'm going to do less than x. So second test, less than, that's going to be option 5, and then x. And then we have to do second math. We're going to go over to logic. We're going to say and, so option number 1. So -5 is less than x, and we're going to say x is less than 6. You got to do them each separately. X, second math, option number 5, and 6. Close parentheses. If I hit graph, we see that part in the middle. Only thing you can't tell from the calculator is the endpoints, the circles, but we can kind of see which one is matching. And then if I go back to y equal and do the last part, we can do 1 divided by 3 x, and then divided by, and then I'm going to put this in parentheses. Now, I didn't put the first part in parentheses, but you definitely need to. It it helps, let me just do it to stay consistent. Second, insert, open parentheses, and then I go behind the X. Second, insert, close. There we go. All right, so we want X is greater than or equal to 6. So X, second test, option number 4, and then 6. And then we hit graph, and we can see the piecewise function that matches was D.